Welcome to online digital classes. Students, today I brought an interesting and an important math content for you, and this is one of the most important math topics for your future mathematics. Okay, without making any delay, let us jump to the topic. Today's topic we are discussing is factorization. By the end of today's class, you will be learning different methods of factorizing a given expression and also the importance of factorizing a given expression. There are two mathematical expressions, x plus 3 and x minus 3. What do you get if you multiply these two mathematical expressions? Yes, that is x square minus 9, which you have already learned in the previous chapter, algebraic expressions. And similarly, let us take 2x and x plus 1. These are the two mathematical expressions. If you multiply them, here you get 2x square plus 2x. And let us see one more example, 2y and 5y. These are the two mathematical expressions, and if you multiply them, what do you get? 10y square. You observe here, when you are multiplying two expressions, you are getting one answer. This is called product. So, product of these two expressions. Suppose you take them in reverse order. That means, here you see x square minus 9 is splitted into two mathematical expressions which are under multiplications. That means, x square minus 9 is expressed as x plus 3 into x minus 3. Similarly, 2x square plus 2x is expressed as 2x into x plus 1, and also 10y square equal to 2y into 5y. So, this way of writing a single mathematical expression into some terms which are under product is called factorization. This is the topic we are going to learn today. And now again you see here another number 48. How do you express 48 as a product of terms? You can write it as 6 into 8. This is called factorization. This we have already learned in our lower classes. 48 can be written as 6 into 8. This is factorization. And you know already that this 6 can also be splitted as 2 into 3 again. So, thus you can write 48 as 2 into 3 into 8. This can also be called factorization. And again 2 into 3 into, and what about 8? 8 can also be splitted into 2 into 4. So, it can be written as 2 into 4, and this way of writing 48 is also a way of factorization. This is also called factorization. And you again know that 4 can also be splitted, isn't it? 4, the number 4 can also be splitted. So, I write this as 2 into 3 into 2 into, again 4 can be splitted as 2 into 2. Now, you observe at this step, every term 2, 3, 2, 2, 2, these all are prime numbers. Can you split any prime number further? No. This is the last stage of factorization, and these factors are called prime factors, and this step is the last step of factorization, and this is called prime factorization. And the similar way, suppose you take a term 7xyz. How can you write this 7xyz, this single term, as a product of terms? You can write it as 7 into xyz, and you know already that this xyz can also be written as the product of terms. So, I write it again as 7 into x into yz. Can we call this is the last stage of factorization? No, we can further split this term yz also. So, I write this as 7 into x into y into z. So, this is the last stage of factorization, because we cannot further split any term 7, x, y, z. We cannot split them further. 7 into x into y into z is the last stage of writing factorization. So, these terms 7, x, y, z, which we cannot split further, these are called irreducible factors. So, when you write a term as the product of irreducible factors, this will be the last step of factorization. Even though all the above 3 steps are the factorization steps, above 2 steps are the factorization steps, but this will be the last stage of factorization because we cannot further factorize it. Now, let us see what are the different methods we have for factorizing a given expression. So, we have the first method, a method of common factors. This is the first method. Next, we have another method, grouping the terms, and the next method we have using identities, factorization using identities, and the last method we have in our class is splitting middle term, that means using a different format. Let us see all these 4 methods now. So, let us start with the first method, method of common factors. Let us take one question. See here, factorize 7xy plus 3x square. We have to factorize this question using the first method, method of common factors. Okay, let us start. Take the question 7xy plus 3x square. Now, you see carefully how I am writing this 7xy. This 7xy is splitted as 7 into x into y. That means it is factorized using irreducible factors, 7 into x into y. Similarly, I will take 3x square, and how can we write this 3x square? 3 into x. So, in that way I have splitted the 2 terms as the product of irreducible factors. Now, you carefully observe here from the 2 parts we have one letter common. Here you see which is highlighted. This is x present in the first part, and there is another x present in the second part. So, we call this as the common part. The term which is present in both the parts is called common part. That common part is taken as common. So, x from here is taken common, and we write the leftover terms in the bracket. What are the leftover terms? Let us see. In the first part you have taken x common, x is taken outside. What are the terms remaining here? 7 and y. So, we write it as 7y. The leftover part is 7y from the first term, and what is the remaining term in the second part? Here one x is taken outside. So, the leftover part is 3x. Thus, 7xy plus 3x square is written as x into 7y plus 3x. So, writing this 7xy plus 3x square in this way is said, we can say that this question is said to be factorized. Isn't it interesting, students? Now, let us see one more question under this method. See, 3a square bc plus 6ab square c plus 9abc square. Let us try to factorize this using our first method, that is method of common factors. What we need to do to apply this method? We have to split each term. Here there are 3 terms. We have to split each term into irreducible factors. How do you split this term as irreducible factors? You see here, 3 into a into b into c, isn't it? Here 3 is written as 3, a square is splitted as a into a and b into c. Likewise, the second term 6ab square c, how can you write this as the product of irreducible factors? 6 can also be splitted like this, 2 into 3 into a into b into c. You observe here 2 into 3 is 6, a, b into b is b square and c. Similarly, the third part 9abc square, third term can also be splitted as 3 into 3, because it is 9 can also be splitted 3 into 3, a into b into, there is c square, that c square is written as c into c. Now, what is our duty now? From the 3 terms, here there are 3 parts, we have to identify which terms are common. Now, I have shown you one number which is highlighted here, which is common in the 3 terms. 3 is there in the first term, 3 is there in the second term, 3 is there in the third term also. So we can take 3 as common. Now again you observe, is there any other letter also common? Yes, it is there. A is common in the 3 parts. So we can take A as common part. And don't stop, you have to search whether there is another letter is also available as common from the 3 parts. Let us search. Yes, B is also there in the 3 terms. B from the first part, second part and third part, you can take B common. And last but not least, C is also common from the 3 parts, C, C, C. So we can take C also common. And now we have to write the leftover parts inside the bracket. Now you observe, from the first part you have taken 3 as common, A as common, B is also taken outside, C is also taken outside. Then what is the term left from the first part? It is A. Simply only one letter is left, A. And from the second part, 3 is taken common, B, A is taken common, B, C also taken common. The leftover part is 2B. And from the third part similarly, 3 is left over there and C also. So 3C. Thus 3ABC into A plus 2B plus 3C. Thus the given question 3A square BC plus 6AB square C plus 9ABC square is now factorized as 3ABC into A plus 2B plus 3C. How can you say this question is said to be factorized? Because all the right side terms are under multiplication. 3ABC means 3 into A into B into C into and this bracket. Thus this question is now said to be factorized. Isn't it interesting, students? We have completed the first method of factorization. Now it's your turn. You just try to solve some questions. See here, I gave you 2 questions. The first one 5x square minus 25xy, and the second question 36a square b minus 60a square bc. Using the first method, try to factorize these 2 questions. Now let us go to the next method, that is factorization by grouping the terms. Yeah, here is a question for you. X cube plus 2x square plus 5x plus 10. Let us try to factorize this question. X cube plus 2x square plus 5x plus 10. Let us first split each term into irreducible factors as we have done earlier. So here x cube is written as x into x because it is cube, we multiply it 3 times. This is 2x square, 2 into x. This is 5x, we can write it as 5 into x. This is 10, of course it is 2 into 5. So we cannot apply the first method. Now what we do here, we group the first 2 terms. We make the first 2 terms as one group and the next 2 terms as the another group. There are 2 groups formed here. And from the first group, which is common, you observe what term you find as common. Here x is common and there is another x also common. So x into x is common from the 2 terms. So I take x into x as common. And what is the remaining part from the first part and second part? So what is the term remaining here in the first part? X plus here 2. And similarly, you go for the second group. What is the common term from the 2 parts? Yes, it is 5. So you take 5 as common. And what are the leftover terms inside the bracket? X plus 2. And here x into x, you know very well we can write it as x square, of course. So I write x into x as x square. Now you observe, again there are 2 terms. And in the 2 terms, we have x plus 2 common. So that's why I have taken x plus 2 common. X plus 2 is there in the first term, x plus 2 is there in the second term. So I have taken out that x plus 2 as common and write the remaining part inside the bracket. So, what is the remaining part inside the bracket? So, it is x square from the first part and it is 5 from the second part. Thus, you observe now the given question is factorized. It is written as the product of two expressions, x plus 2 into x square plus 5. So, this is said to be factorized. Yes, we shall go to the next question now. Look here, factorize a cube minus a square b square minus ab plus b cube. Now, what we do first? First, we split each term into its irreducible factors. A cube as a into a square b square as a into b minus ab as a into b and b cube as b into b. Now, what we shall do? We have to make them into groups. The first group and this is the second group. And what is the part that is common in the first group? A into a. So, a into a is taken common. And what is the leftover part, leftover term from the first part? It is a and it is b into b. Now, you take common b minus b from the next group and then what is the leftover part from the first part, leftover term from the first part? It is a, because minus b is taken common, minus is taken common, b is taken common, then a will be the remaining part, remaining term in this part. And what do you write next? It is negative sign. Don't write this positive sign here because that positive contains two negatives. A positive means product of two negatives. So, we have taken one negative common. So, another negative is remaining there. And what about the terms? B is taken outside, one b is taken outside and two b's will be left over. So, that is b into b. Now, I can write a into a as a square and this b into b as b square. Similarly, a minus this is also b square. You observe the same interesting thing what we have seen in the previous problem. A minus b square is again there in this first term, a minus b square is there in the second term. So, you can take a minus b square as common again. So, a minus b square is taken common and we write the remaining part inside the bracket. What is the remaining part from the first term? A square minus this minus b is the remaining part from the second term. And after completion of second method, now you have two questions on the screen. You try to solve, you try to factorize these two questions using the second method, p square q minus pr square minus pq plus r square. This is the first question. And m square minus mn plus 4m minus 4n. Try to solve these two questions using the second method. And now it's time for us to go for the next third method. What is the third method? Factorizing using identities. You have already learned these identities in your previous class, isn't it? See here, a plus b whole square equal to a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square, and a minus b into a plus b is written as a square minus b square. These are some of the identities you have learned in your previous chapter, of course. Now, I will write these identities in reverse order. Now, you observe a square plus 2ab plus b square is written as a plus b whole square. A square minus 2ab plus b square is a minus b whole square. A square minus b square as a minus b into a plus b. And you know very well what is the meaning of a plus b whole square. It is a plus b into a plus b. What is a minus b whole square? A minus b into a minus b. And here a minus b into a plus b. That means this expression a square plus 2ab plus b square now is said to be factorized, isn't it? A square plus 2ab plus b square is written as the product of two terms. That means here also we can say this is factorized, this is also factorized, and this is also factorized. So, using these identities, let us try to factorize some expressions. So, we have one question for us on the screen now. X square plus 4x plus 4. Now you see here, can you try to solve this question? Can you try to factorize this question using the first method or second method? You try yourself. Of course, it may be some sort of difficulty for you, but now you see how I am going to factorize this. So this x square plus 4x plus 4 is written as x square plus 4x. Here I am writing 4x as 2 into x into 2. So that if you multiply these 3 again, you will get 4x back. And this 4 again as 2 square. Now observe this step. Are you getting any identity in your mind while seeing this expression? Yes, a square plus 2ab plus b square. This part is just looks like a square plus 2ab plus b square, and just now we have seen how can we write this a square plus 2ab plus b square, a plus b whole square. So like this expression, how we are writing this as a plus b whole square, we can also write our question now x square plus 2x into 2 plus 2 square, as we can write this as x plus 2 whole square. So x square plus 2 into x into 2 plus 2 square can be written as x plus 2 whole square. That means x plus 2 into x plus 2. That means it is now factorized because we have written it as the product of two terms. Now we observe another question. 25m square minus 40mn plus 16n square. So I can write 25m square as 5m whole square minus 40mn as 2 into 5m into 4n. And by seeing this, you have to get one identity in your brain. What is that? A square minus 2ab plus b square. And we have just seen how can we write this a square minus 2ab plus b square as a minus b whole square. Now similarly, take our question 5m whole square minus 2 into 5m into 4n plus 4n square. This can be written as 5m minus 4n whole square. Why? So instead of a, here we have 5m, in place of b we have 4n. So here instead of a minus b whole square, we can write 5m minus 4n whole square. Thus the question 5m whole square minus 2 into 5m into 4n plus 4n whole square can be written as 5m minus 4n into 5m minus 4n. This is how I factorized this using third method, that is using identity. We shall see one more example, 6x square minus 54. Students, you observe this question carefully. We cannot apply the identity directly because 54 is not a square number. But you observe, we can apply first method because 6x square can be written as 2 into 3 into x into x. So you split into irreducible factors, 54 as 2 into 3 into 3 into 3. Now we have one part of term we can take common, 2 into 3, 2 into 3. So we can take 2 into 3 as common. And what is the remaining part? X into x, that is x square, and 3 into 3, that is 3 square. And 2 into 3 we can write it as 6. So that means I factorized this already. This is the way of factorization, but this is not the last stage of factorization. We can apply identity inside the bracket. You see here a square minus b square. It looks like a square minus b square. So we have already learned a square minus b square means a minus b into a plus b. So 6x square minus 54 is written as 6 into x square minus 3 square, and this x square minus 3 square we can write it as x minus 3 into x plus 3 because as 6 into x minus 3 into x plus 3. Now students, it's your turn. You try to factorize the following questions that you see on the screen using the suitable identities. Observe the questions and you select one suitable identity, apply the identity and factorize the questions. And we have one last method of factorization. So factorizing by splitting the middle term or factorizing expressions of the form x square plus a plus b into x plus ab. Now you see x square of a plus b into x, this a plus b into x can be written as ax plus bx, right? A into x ax, b into x bx. Thus you can take x common from the first two terms, then x plus a is left in the bracket and b common from the last two terms, and x plus a is remained in the bracket. Thus, we can write it as x plus a into x plus b. X plus a is taken again common, here x is remaining, here b is remaining. So, thus this question, if the question is in this form, x square plus a plus b into x plus ab, then we can write that question into this form, x plus a into x plus b. That is, now this question is said to be factorized. Let us apply this form to one question. Now, we have one question here on the screen, a square plus 10a plus 24. Now, you see how I am writing this. See here, a square, 10 is written as 4 plus 6 into a and 24 as 4 into 6. Make sure what are the numbers you take here, the same numbers you should take here. 4 plus 6 if you take here, the same numbers you should multiply here. Now, we have just seen if the question is of this form, we can factorize this into this form. So, now this question is just looks like this above step, a square plus 4 plus 6 into a plus 4 into 6. So, you can write it as a plus 4 into a plus 6, isn't it? Instead of a we have 4 here, instead of b we have 6 here. So, thus the given question is said to be factorized. Yes, let us see one more example under this method, x square minus 4x minus 32. Think how can we write, how can we split this middle term? See how I am writing here, x square minus plus minus 8 plus 4. How I am writing minus 4 here? Minus 4 is written as minus 8 plus 4. If you simplify minus 8 plus 4, you get minus 4 back. And this minus 32 again as minus 8 into 4 I said already. Make sure you must take the same terms here. Minus 8 and 4 here, the same minus and 4 here it should be. Thus, when the question is in this form, we have already discussed we should write in this way. Now, our question just looks like this above step, x square minus plus a minus 8 plus 4 into a plus minus 8 into 4. Now, thus I applied this identity and I have written this as x minus 8 into x plus 4. The methods of factorizing a given expression. What is the importance of factorization? Where do we apply this factorization? So, now you observe these division problems that on the screen. Here you see x square plus 7x plus 12 is divided by x plus 3. How can you divide this expression using this expression? So, here we apply factorization. That is the importance of factorization. Now, you see we can write x square plus 7x plus 12 divided by x plus 3 in this way, and the numerator you see here, this is of the form x square plus a plus b into x plus ab. We can split and we can factorize in this way, x plus a into x plus b. So, thus using this identity, I split the numerator as x square plus 7 as 3 plus 4 into x and 12 as 3 into 4. Thus, you can apply this identity to this numerator, and x square plus 3 plus 4x plus 3 into 4 is written as x plus 3 into x plus 4 by x plus 3. Here x plus 3 and x plus 3 gets cancelled and the remaining answer is x plus 4. Okay students, now it's your turn. Work out the following divisions. X square minus 8x plus 12 divided by x minus 6, and this is the second question, 15ab into a square minus 7a plus 10 divided by 3b into a minus 2. Divide these, do these all divisions and apply suitable factorization methods to the numerator and find the answer. Okay students, that's all for today's session, and we will meet in another session with another important math topic. And for better understanding, work out all the worksheets given to you and visit the official website of SCRT for worksheets. Thank you.